Okay, you are constructing the triangle with a given measurement, side lengths of 2 centimeters and 2 centimeters. Have you got that constructed on your paper? Okay, I want somebody to bring it to the board, please. I'm going to let Cadence come up here and put that on the board, please. And then you drag it. Okay, now remember, your measurement doesn't go past that. So you've actually got it a little bit larger, right? Okay, put your finger on the numbers and then see there, okay? That'll let you rotate it. If you put it in the middle, it moves the whole thing. It's tricky, isn't it? Nice job. Nice job. Now, what type of a triangle did she draw? And she did a really nice job there. An acute, I'm hearing the word acute. What else? What other kind of triangles? What would some other classifications of this triangle be? What was that over there on the left?
Right.
Right. Okay. We could call it an acute right or a right acute. Okay. What was that, Joey? Isosceles. Good. L-E-S?
Yes.
Isosceles? I'm not sure that's spelled right. Okay. Where's the C?
After the second S.
I knew that wasn't right.
I used to want
Isosto. Spell it.
ISOSCELES.
There we go. Isosceles. We've got 3 different names for it, but they're all talking about the same triangle. Madison.
Wouldn't it be an equilateral since all sides equal to
Ah, were all sides supposed to be equal?
No.
Side length.
Because the angle is.
But this one's not going to be that way, is it? Because of the fact that it's a right triangle, it couldn't be.
Yeah.
Was it supposed to be, though? According to this,
How is it a right triangle? Yeah, it's acute. How is it right?
good question. Can it be a right triangle if it's acute?
No, because 90 degrees.
Good. Okay, so this is not accurate. Can't happen. Or no, that can happen, but it can't happen with right. Is this one a right triangle the way it's been drawn?
No.
Did you draw a right triangle, Cadence? No, but did you measure this other angle, the third angle? No, so you're not really sure whether you got the right. Okay, so it could be acute. Could it be isosceles then? Are all acute triangles going to be isosceles? Some of them maybe? Maybe that's something we might have to discover. Do you agree? Because it could be an equilateral if all 3 of these sides measure 2 centimeters each. It would be an equilateral. Okay, because equilateral meaning the same. Yes, Maddie? Okay. However, we haven't necessarily identified that to be. Okay, what about the second one? Side lengths of 7 centimeters and 10 centimeters. And we're looking at centimeters.
Yeah.
Yeah, it won't fit on the little square, but it will fit in the other space that I gave you. Okay? So one line or one side has to equal 7 centimeters. One side has to equal 10 centimeters. Those are the two requirements. Would a right triangle maybe be the easiest with this one? It really would. Okay. Do I have somebody that would like to come and try their hand at creating on the smart board? Glenn. I don't know if that's going to give you enough space because that's all in inches and not centimeters. So you wouldn't need it.
Yeah, there's no more rulers.
Are you
The only one in there only has inches.
Yeah, I got it.
Have we already used rulers this year?
No.
Because I didn't put them all in there because it's kind of like my protractors, like the one on the floor. They are disappearing or getting broken or just not coming back. Where did I put the extras? The rulers tend to get broke because people use them as whackers. They whack them on the desk. If you have protractors in the 8th grade room, make sure you get them back in here. Okay, kiddos? Because we are going to be using them still. And I really don't want to have to put them on a school supply list and make your parents buy them. Yeah, and this drawer was completely full when we started this year. All right, Chief. Nice job. Where's your 7 centimeters? This one's 7? And where is the 10? This one's 10? Okay. All right. Everybody should have a 10 centimeter and a 7 centimeter side. All right? Making sure when you're using your ruler that you don't start at the end of the ruler, that you start where the 0 is. Madison. Madison says that is a scalene triangle. Why, Madison?
Because not all sides are equal.
Scalene, not all sides are equal. Do we know anything else about it? Do we know anything else about it, Joey?
It's in the
Joey says it's acute.
Right.
It does appear to be an acute triangle. I wouldn't know for certain without measuring. It does appear to be cute. I heard somebody say the word, I heard somebody say it was right, and I don't think that's possible. Whoa, I don't want to make it go away. Can I undo? Go.
Maybe it could go multiple times.
Hit the one up there, like the black one up on the top.
Yeah. Nope, that didn't help me.
Well, yeah, because it's not.
I don't know. It went away. Sorry about that. We're gonna go about, that's not as good as it was. But if I throw that in there though, is that really gonna be a right triangle? No way. Because this doesn't make it. It would have been a right angle there. So, and now on this one here though, look at it. Is it greater or less than 90? It's greater. So more than likely it's going to be a scalene obtuse triangle, okay? All right, we've been talking about constructing and classifying. And on your notes you would have seen these classifications. Acute, obtuse, right, and equiangular. Equiangular means that all angles are equal. Okay? All angles are equal. Okay? And that's what the little symbol here means, congruent. You see the congruent symbol. Okay? Anytime you see those little arcs right there, it's telling you they're congruent. Just like, what does this little red arc mean that's here? Okay? That stands for our 90 degrees for our right angle. Classifying, so we can classify them by their angles, we can classify them by their sides. Congruent sides will have the same length. Okay, so a scalene triangle has no congruent sides. Nothing is equal. An isosceles triangle has at least two congruent sides. And a equilateral triangle has to have 3 congruent sides. Joey.
So if it has, this is at least, so does that mean there can be more than one? So an equilateral triangle would also be an isosceles?
Very good. An equilateral triangle would also be an isosceles because it has 3 congruent. Does it meet the qualifications for isosceles? Yes.
I like how a rectangle is a square. Or a square is a rectangle.
A square is a rectangle, but a rectangle is not a square.
It's not.
Correct. Okay? Any questions there? Let's see. Okay, classify the given triangles. You've got them on yours. This first one, what do we classify A as? What am I going to classify A as? Anna? Pardon? Obtuse? Scalene? Now, why do you say scalene?
No equal sides.
No equal sides. It doesn't appear to have any equal sides. Is that an assumption that, yeah, we can make? On that one, it's pretty easily made. Do you agree?
Yeah, 'cause we'll have
Okay.
more.
Obtuse, scalene. Could I say scalene, obtuse?
Yes.
Yes, it doesn't matter. The order of which way you classify there doesn't matter. Okay? What about B? What is B? What type of a triangle is B, Molly? Molly says acute. Now, can you be certain about that, Molly? If you measured it, you could be certain. You could try, but if it's not drawn to scale, that might not be a really good way to go, okay? What else do you know about it that you know that you can hang on to? What else there, Chase? Chase says isosceles. Why?
Because there's only 2 congruent sides.
Good. 2 congruent sides. We've got this side and this side are equal, all right? What about by our angles? Could we? The acute pretty much gets that. If these two are equal, another where you don't have to measure. If those two are equal, is there any possibility that this one here is a 90 degree? No, no possibility in looking at it. So I would say an acute isosceles would be a very good assumption there. Okay, very good. Isosceles, acute. Okay. What about number 1? Somebody that hasn't talked to me. Dakota, number 1. What type of a triangle is it? It is a right triangle. And if you're writing this for your homework, you could say it this way. Right triangle. The little triangle tells me that's what I'm talking about. Okay? What else do you notice there? What do you got, Tyler? Isosceles, okay. Okay. Why is it isosceles? Two equal sides, good. Okay, so we have an isosceles right triangle or a right isosceles triangle.
Would it also be like a cube?
Could it be acute?
No, because that's
have
all
all
three. Oh yeah.
Okay, if it's an acute triangle, it has nothing greater than 90 or greater. It all has to be less than 90. Okay, the degrees have to be less than 90. So have we answered all the classifications that we could with number one? What about number two? Number two, Ridley.
Equilateral.
She says equilateral. Equilateral. Okay. Can you classify it in another way, Justin?
Isosceles.
It could be classified as an isosceles. What else? What are some other names that or classifications, Shelby?
Equiangular.
Equiangular. How do you know that, Shelby?
Because all three are
Good. Any other classification here? We've got an equilateral triangle, isosceles triangle, equiangular triangle. Anything else? Cadence?
acute.
Acute. Why?
Because there's no angles that are greater than 90.
Right. There's no way there'd be any angle greater than 90. All the various classifications. And we didn't stop with just one. We classified it in every way that we could. Okay, on your homework today, you're going to want to classify in all the various different ways. Okay? Draw a triangle. Draw a triangle with measures of 30 degrees, 60 degrees, and 90 degrees. Then classify that triangle. So you're going to draw a triangle with 30, 60, and 90. Let me erase it. If I get rid of that, maybe then I could. No. You guys are gonna have it drawn before I can get it drawn up here. This one. Okay, so we had to have a 30, a 60, and a 90.
Yeah.
That didn't work. I don't have it. I don't have it drawing it up here because I can't get my protractor to let me do it the way I want it. Do you have it? 30, 60, 90.
Kinda close, I think. This looks close.
It does look close. Once it's drawn, what type of an angle or triangle is it? 30, 60, 90. What are we going to classify it as?
Right.
I've got a right triangle. I have a scalene. $30, 60, 90. It's not acute. It's not obtuse. Anything else that I know for certain I can label it? G?
It's a 930.
Okay. Right triangle or scalene triangle. All right. Right scalene would get both sides and angles. Do we agree? Okay. We're not going to do that. We're skipping that one. Going right to that one. Okay. Your assignment, 2.3 exercise. When I look at that, or that should say 7.3 exercise, not 2.3. That should be 7.3. Let me see if I can fix that. Okay, you might make note on that if on your notes that it is 7.3, not 2.3. Okay.